Good afternoon. Welcome to the latest in the series of seminars and webinars on the Engineers Ireland Accreditation Criteria. In previous sessions, we've covered off the changes in the 2021 criteria and also looking at the treatment of ethics as part of the criteria. In this session, we look at accreditation criteria number 8, which is engineering management. This is a new criteria that's been added to the 2021 version. We'll look at that in a little bit of detail. Today's speakers are myself, Damien Owens, Registrar Engineers Ireland, Conor McMahon from TU Dublin, and Paul Cochran from PM Group. So we're going to spend, I suppose, about 15 minutes each just discussing our own particular perspective on this accreditation outcome, and then we'll have a Q&A. So the seminar is being recorded. However, we will stop recording for the Q&A session at the end. So briefly looking, hopefully the slide's going to change. Okay, we have, yes, change. So briefly looking at the accreditation criteria and where they've come from. So we updated the criteria in 2021 from its previous 2014 version. As part of that process, we had a fairly comprehensive consultation process with industry, with academia, and international organizations. And in arriving at these criteria, we strive to maintain that the criteria, first of all, meet international standards, but reflect the requirement for current learning in the engineering sector, and also reflective of the fact that Engineers Ireland is party to a number of international agreements and accords, which assures that the recognition of graduates of engineering colleges in Ireland, that their qualifications are recognised overseas. So Engineers Ireland accredits programmes at NFQ level 6 to 9 at all universities and institute of technology in Ireland. It's an outcomes-based process, and what that means is when we undertake a review of a college seeking accreditation, we're looking at exactly what did the students learn. So we're looking at outcomes and focus on the skills and abilities that are learned. We undertake a review every 5 years, and the review panels comprise members from academia and industry, ensure that we have that industry relevance and perspective, and we have that again here today. The colleges make a self-assessment report. We undertake a visit, typically 2 days on site, but obviously in the current environment, much of that is online. And we look at evidence. So, for example, we look at exam papers to make sure the questions are at the right level. We would then look at the exam result, the students' responses to those exam questions to see how they are addressing the learning outcomes. We also interview the academic team. We interview students to see what they think of the program. We interview graduates to see what their experience of it was now that they've left and they've prepared for work. And we interview industry employers to see are the students at the graduates at the right level. So it's a full 360-degree process. And in terms of governance, the panels then present the reports to the Accreditation Board of Engineers Ireland, which is then endorsed by the Executive Board, and the programs are then listed on our website. And our first accreditation was in 1982. We currently have about 230 accredited programs. And the database of current historical programs are available on our website. And they're usually consulted, just to give a real world example, they're usually consulted by immigration authorities for somebody seeking recognition for, say, migration to Australia, the US. They would look at the website to ensure that the qualification is indeed recognized. So today we're looking at Program Outcome 8, Engineering Management. As I said, this is a new program area added to our criteria for 2021. And this is concerned with knowledge and understanding of basic engineering management principles to the branch of engineering and an ability to apply these in one's own work. And really what we're looking here is to instill in students an appreciation of organizational structures, commercial governance, legal principles, an understanding of management techniques and resources, and work planning and monitoring tools such as project management. And it's important to add here that, we're not looking at creating accountants or lawyers or HR specialists, but really to give a context to the students that when they go into the workplace, where they will fit in the corporate world or even in a smaller industrial setting where they may be the lead person in a small organization. So to put a global perspective on this, Engineers Ireland is party to a number of international agreements. Many of you will have heard of the Washington Accord, which looks at the recognition of academic level for a professional engineer. We're a signatory of that accord. And there's also we're a member of ANA, which is the European Network for Accreditation in Engineering Education. And that is a similar set of criteria which are recognized globally. So in arriving at our own criteria, we must be cognizant of what's demanded by these international accords. So the International Engineering Alliance on the left-hand side here has their graduate attributes and profile professional competencies. And these were updated in the last 2 years to reflect the UN Strategic Development Goals. And you see there they've been endorsed by UNESCO. And this has informed much of the input into Programme Outcome 8 that we're going to discuss today. And then we also have the EURACE, which is the NA framework standards, which are undergoing a similar sort of review process at this time. So looking at the Engineering Alliance, they set out a number of graduate attribute profiles, which cover the main areas that we'd expect engineers to cover in their education. And the first obviously is engineering knowledge, problem analysis, design. So it's all what we would call the core engineering areas and knowledge areas. And then moving down, we look at investigation, tool usage, and the engineer and the world, and how the engineer fits into the world, ethics, individual and collaborative teamwork. So really what we're focusing on today then is outcome number 10, which is project management and finance, the level of management required for different types of activity. And again, it's getting that engineering perspective into the real world. So I suppose to put in perspective, engineers work with others, and the role of Programme Outcome 8 is to provide engineering students to view their role in perspective of other specialities that they'll encounter in the workplace. For example, engineers will have to explain the work to do, for example, to accountants to get financial approval or to do budgets for their work. So it's understanding how to explain what they're doing in non-technical terms to another specialist. And similarly, if they want to undertake a piece of research or set up a production line, there will be HR implications, manpower implications. And again, it's understanding where the engineer fits in those cycles in the workplace. To understand, I suppose, the broader impact of an engineer's work in areas such as project management of timelines, and you're managing more than just the clock. Again, there's a cost and the manpower implication in that context as well. Looking at materials, adding components, reducing the component count. Are those components recyclable, reusable? And then looking at other aspects, for example, something that's often overlooked is the legal communications aspect. So it's just being on top of that when undertaking projects. And in global context, sustainability and UN SDGs, which have been worked in through the accreditation criteria as fed through from the IEA and the NA graduate attributes. And important to note here, and I suppose we all are aware that the engineering curriculum in colleges is quite full. We expect a lot of engineering students. So what we're not doing here is developing accountants or HR managers. What we need to do is to make sure that the engineers have the appreciation of the impact of some of the work, but they do not need to be doing full profit and loss analysis and balance sheets or anything of the sort. And I suppose looking at a broader perspective, that we need to reflect that engineers don't just make things. While engineers are inventors and develop products and services, we also invent industry sectors. And we've seen that in the last number of years. If you look at social media companies, many other new companies that we see, tech giants that have really come into play during the pandemic. And many of those are founded and driven by engineering talent. So we need to, I suppose, instill in engineering students that they are more than just makers of things. They are creators of an industry, creators of value for the economy, and creators of jobs. So, you know, engineers should see their role as entrepreneurs and leaders, and shouldn't really shy away from that. I think engineers should take pride in the work that they're doing and the competence they have developed, and certainly move forward with that. So looking at the core documents, we have accreditation criteria, but we also have a procedure for accreditation of engineering programs, and that really is looking at how we do the assessment. So accreditation criteria sets out what the HEI, what the higher education institutes must do and must impart to students, whereas the procedure sets out how do you demonstrate the evidence of what has been achieved by the students and how it's supported. So looking at it from the academic perspective, how do we demonstrate achievement of program outcome 8? Well, here's some examples. Multidisciplinary and project teams provide an ideal context in which engineering students can see how they fit into teams and how they work with others. And in the college context, we typically will see engineering schools teaming up with business schools and developing joint projects, particularly when you see some spin-out work there. So they're ideal opportunities. Project work, final year projects, even mini projects. We look in there to see, has the student considered the cost implications of the project, or the component count, or environmental aspects, the social implications of a project. For example, if they're looking at a wind farm, are they looking at it in the whole context? And the impact on personnel in any organization or wider community. For example, is additional training required on any product or service that they do? So it's taking a very much a holistic view from cradle to grave of the work they're in, and also looking at the quality of the products that they're developing. So in conclusion, from my perspective, the whole point of Program Outcome 8 is to ensure that engineers have an awareness of the broader impact of their work in workplace and societal settings, but encourage a larger perspective, a broader perspective, the importance of the role of the engineer in terms of industrial development and creation, and technical, and that they are, if we use the current parlance, rather than being social influencers, we are also technological influencers, and we should take that role on seriously. And not only that, it doesn't stop when the graduate graduates from college, but they need to prepare this for lifelong learning. So I'm now going to hand you over to Conor McMahon from Technical University Dublin, who will look at some of the entrepreneurial aspects. Thanks, Cormac. I'll stop sharing.
Thanks, Damien. I'm just going to share my screen here now. Bear with me. Sorry about this, just make sure I get this on the screen. Everyone can see that okay?
That's good, yeah.
Great, thanks, Damien. So my name is Cormac McMahon, and really what I hope to do today is perhaps just share maybe an educator's perspective on this, and just a little bit about me, not because I just want to talk about me per se, but I think perhaps my own career is probably pretty typical of what an engineer might go through from their point of graduation. So I studied mechanical engineering in UCD and graduated in 1994. And for the first 10 years of my career, I worked with several multinationals, including Shell and Hewlett Packard and Emerson and BICC Cables. In 1998, I undertook a part-time a master's in industrial engineering at UCD, and it was probably really my first exposure to many of the engineering management principles that are now enshrined in the program accreditation criteria. And immediately following my master's in industrial engineering, I completed an MBA, which in many respects is classical professional management. Since 2002, I've been lecturing at what is now TU Dublin, but at the time was Institute of Technology, Blanchardstown, and more recently I completed my doctorate in business administration, which is really, I suppose, if I was to try and best describe where my current activity is in terms of my career, it's really focused on management research and management education. So I think there's a nice synergy there between, if you look at that gradual transition from being a graduate engineer, where you're very much focused on the technical and technology aspects of the engineering role, over time moving into an engineering management role, and essentially taking those principles and applying them in an education context. Here's just a list of, I just went back over my old transcripts actually during the week to see what subjects I actually studied, topics I actually studied as part of each degree, and how they related to management. And I think Damien aptly described it as, we're not trying to make engineering students experts in accountancy and finance and so on, but the more we can give students exposure to these topics, these issues, and indeed give them opportunities to practice and learn, the better from the point of view of their own development. So as part of my Bachelor of Engineering degree, I can recall distinctly studying, I suppose, a classical financial accounting 101 course where we did learn a little bit about profit and loss, balance sheets, and also things like how to look at ratio analysis and so on. We also studied some basics of contract law, production and operations management, and like every engineering degree program, there was inherently a considerable amount of project work, and project management principles would have been embedded into those projects, either through practice or also through direct learning of what project management is all about. Interestingly, in terms of my master's in industrial engineering, I think much of the focus shifted from applying the basic design principles of an engineer that an engineer learns, and instead of designing, let's say, physical products, it focused in on designing organizations and processes. So there was a shift in terms of the focus of my studies from being purely, again, about mechanical things or electrical things to applying the learnings that we had in our undergraduate degree to real management issues. And much of the learning during that Masters in Industrial Engineering focused in on some of the sort of hallmark management principles, such as scientific management from Frederick Taylor, the management principles from Fayol, and things like the Hortown effect and motivation from Hertzberg. Things like this became sort of seminal sort of learnings as part of that industrial engineering degree. And I suppose, reflecting back on it, I think the big difference was that that perspective on management was very rational focused. So it was about applying scientific and engineering principles to organizations and to people, as opposed to things or to machines or to products and so on. So it was a stepping stone, but I guess the MBA then was probably, for me personally, the single biggest transition into management learning, and I suppose opened up a much broader viewpoint of what management was that I hadn't had up until that point. And finally, just I suppose a comment on my recent DBA, which are Doctorate in Business Administration, was really focused on management research and theory. But I just wanted to, I suppose, the reason I just described that personal journey there, I think, was because it's important to, when we look at, education programs and preparing students for entry into a profession such as ours, we have to think about various factors within those education programs that contribute to what I'd call professional preparation outcomes. And just because you graduate as an engineer after 4 years of study, obviously doesn't mean you're, a fully fledged professional in your own right. And there's some well-known theories there around the idea that, professionalism or your sense of professional identity really develops over a prolonged period of, practice and reflection post your studies. So, your engineering degree will only bring you so far. And then there is so much to learn after that, either through practice and reflection and more formal learning. The point I'm trying to make here about, let's say, the program itself, and it's, I think, important from the perspective of the, call it the audit process when we evaluate our degree programs against criteria such as the new accreditation criteria from Engineers Ireland, is that we look at various processes within those programs, including how we select the students, the curriculum itself, how we teach, so the pedagogy or our approaches, the learning activities, how we assess the students, and perhaps even more importantly, the role models that our students become exposed to. And beyond those sort of immediate educational processes within the program, I think it's really important to also look at other influences on those professional preparation outcomes. And they would include things like, the institution's academic processes, its quality assurance processes, its governance processes, to ensure that there's actually a high standard being there and in existence to support the program achieving those professional preparation outcomes. So just on to management itself, and I think most of us are probably familiar with this idea of what management is. This is a quite old definition of management, if you like, but it's the classical planning, organizing, leading and controlling. And while it's probably not the most up-to-date sort of metaphor for what management is about, I think from an engineering perspective, it really provides a good metaphor for thinking about the elements of management which we need to expose our students to. The other big issue with management knowledge per se is, if you think about it, engineering has a really well-defined body of knowledge. We're a long established and well-respected profession, but management has always been caught up in this controversy as to whether it can actually be considered a profession or not. And you'll see articles constantly being recycled from management scholars, and you'll see them in popular periodicals questioning the validity of any claims to which might suggest that management is in itself a profession. And there's probably a few wordy or legitimate arguments for suggesting that it's not. So, for example, it doesn't have a defined body of knowledge like engineering or medicine or accounting or other professions. It doesn't have a regulatory body, so you don't need a certain standard of a qualification to be called a manager. And this in itself, while it might seem incidental or academic in discussion, I think does raise challenges for us as engineers, where we have a well-defined body of knowledge that's quite actionable and quite well encoded. I think management doesn't. So in essence, we're being asked, if you think about it, to map something where we have these professional outcomes in our programs to a body of knowledge and skills that perhaps isn't as fully professionalized in the way that we might think about engineering. However, having said that, there has been some really good work on trying to capture what management is all about. And this matrix that I've shown on the slide here probably is a really good way, again, for engineers to think about the elements of management that we might wish to expose our students to. And really, it's looking at 4 forms of capital. So the management of structural capital, which is pretty much about finance and infrastructure, the management of human capital, which is essentially managing people and all the challenges that go with that, the management of relational capital, which Damien has already alluded to, is now incorporating issues around, social responsibility, sustainability, and so on. And then finally, the management of process capital, which engineers typically tend to be really good and really skilled at. So those 4 forms of capital really perhaps help us to think about where engineers can learn what management is all about and how it's related to our professional discipline of study, if you like. Under structural capital, I think, again, this is just my own personal perspective, but I think there does need to be some exposure to financial accounting, including profit and loss, balance sheets, and then basic expressions such as return of investment and return of capital employed, basic cost accounting principles. So how do we cost a product? There's the material cost, the labor cost, and how do we attribute expenses to those products? And I think that's particularly important for any engineer who wants to understand the economics behind the products that they are either designing or making. Much of our role of engineers is focused on major infrastructural projects, so the management of capital is really important. And I think exposure to things like time value of money, net present value, and internal rate of return, basic cash flow and investment principles can be really helpful. Likewise, because inherently our profession is interlinked with technology, technology and innovation management principles, I think, are something that our students can benefit greatly from. And then more broadly, exposure to basic economic principles, whether it be things like GDP and GNP and government financing, and finally, exposure to, I guess, the whole digital world and management information systems, and making sure that our students are digitally skilled when they graduate, I think is really important. Under human capital, again, these are just areas I feel would be very important. So basic exposure to managing human resources, things like motivation, performance, perhaps organizational psychology, depending on the type of degree program, and even exposure to professional development, which I think is particularly important from the point of view of making sure students understand that they're being educated into a profession and they need to continually develop themselves professionally. I think Damien already alluded to teamwork as being really important, and looking for evidence within our degree programs where students learn to work in teams, perhaps even take leadership responsibility for teams, and where appropriate, understanding sort of basic team dynamics and what the risks and development attributes of teams typically are, I think is worth exposure to in an engineering degree program. Health and safety is an obvious one from a human capital perspective. And then moving on to things like organizational design, personnel planning, and also exposure, again, depending on the specific nature of the degree program, to things like employment law, industrial relations, and various statutory requirements that are associated with taking on employees. In relation to management capital, or sorry, relational capital, as I called it, I think there's some really important elements that are probably were well articulated within the the previous accreditation criteria, but I think have been significantly upgraded by, I guess, making sure that they are included now in this new program outcome on engineering management. Understanding, the role of engineers as professionals in society, I think has been, well established within the curriculum for a long time. But I think more recently, the pedagogical supports for that, including things like service learning and citizenship and so on, are probably becoming more and more pervasive within our programs and can add value. Some exposure to general law, I think, is always really useful for engineers, including contract law, understanding the common law system, product liability, and so on. So that the study of law, I think, is particularly important from the point of view of, developing a capability of engineers to manage relationally, if you want to call it that, in the corporate world. So again, we're not trying to make lawyers, but we are trying to give students some basic exposure. Likewise, I think ethics has been in the criteria for quite some time, but I think the idea of bringing that further and ensuring that ethical considerations are evident in the design processes that engineers study is really important. And finally, I just mentioned previously there the idea of professional development, where we encourage students to actively develop their own networks, develop their own professional profile, and engage with their profession, which is by de facto Engineers Ireland in this jurisdiction. The last of the sort of buckets, if you want to call it, of management I've called process capital. And that's really looking at all aspects of processes that our students have to engage with as engineers. Project management is the really obvious one. And by definition, much of our work as engineers is organized as projects, but making sure that the students are not only exposed to the principles of project management, but are exposed then to those principles through practice, I think is really important. Damien mentioned the idea of entrepreneurship being important. And I think if we might not think of entrepreneurship as something necessarily to do with management, but my own view on it is entrepreneurship is a managerial process, albeit it tends to focus on new and nascent ideas and ventures and so on. And I think it's a really worthwhile area of study for our students to be able to, formulate an idea and then learn the management processes associated with galvanizing the necessary resources, very much often outside their own control, to make that idea happen. We typically, might consider that to be classical new enterprise or new venture development, but it can be applied to any project or any idea that, an engineer finds themselves in. Those entrepreneurial skills become really important. For, our manufacturing and mechanical degrees, production and operations management has been a sort of a mainstay within the curriculum for a long time. And I guess more recently in the last 10, 15 years, we're seeing the emergence as well of new product development or as a management process. And I guess I'd like to sort of emphasize it's a process that is beyond the traditional, perhaps narrower engineering view of what new product development is about. So essentially, how do students develop a product using the necessary cross-disciplinary expertise, whether it's marketing, finance, materials people, and engineering skills to bring that product to market is really important. And the last one I've put down there, which I think we've probably become acutely aware with because of Brexit and or the challenges in global trade since COVID-19 took hold, is just understanding supply chains and how they work and the issues we have in ensuring that materials and products flow in a controlled way so that we actually receive them when we want them, I guess is very important. And we all know there's significant complexities around supply chain. So that kind of brings me to, I suppose, really finish on the actual criteria itself. And I guess, I suppose I just emphasize that much of this is perhaps my own personal view and it's been painted by my sort of career to date. But if you look at what the criteria states, I think there's a lot of very clear key words in that must be addressed within the programs when we are applying these new criteria. So finance stands out, decision-making, projects, the legal aspects, contractual, management of resources, planning and monitoring. And I know they're just key words, but very often we find, keywords are a great place to start when we're trying to quickly scan something to get an overview as to whether, a program sufficiently addresses this particular program outcome or not. I'm going to stop there, Damien, if that's okay. Thanks everyone for your time and hope you found my thoughts useful.
Thanks, Cormac, for that. There was a lot in there for us to consider. We're now going to Paul Cochran, who's the Associate Director of PM Group, to give us the industrial perspective of engineers when in the real world.
Okay, good afternoon, everyone. Hopefully you can see my screen. Coming up now for everyone.
That's good, yeah.
Yeah, grand stuff. Very good. So just a little bit about myself. I'm an engineer, qualified as a civil engineer, but have spent all my working life as a structural engineer. 20 years with PM Group. Started as an engineer, and I for the last kind of 15 years I've been a manager, if that's a profession. And I suppose working with PM Group, being involved in kind of sectors like in pharma and medical technologies and food and energy and data centers, and then on projects both in Ireland, in Europe, even further afield now in the last couple of years. So I'm going to give you a little bit of a flavor of what we teach our graduates on our 2-year graduate program, and I can see a lot of similarities in what we are teaching our graduates with what both Damien and Cormac have been talking about. So the reason we run a 2-year graduate program is we obviously take in 150 graduates every year. Globally, we run this program through all our offices, and obviously we're trying to get more management skills. The engineers will get their own kind of technical skills on the job, but we feel that the skills that we teach in our graduate program are kind of critical to our business. And we do include foundational management skills, as well as work-based learning experiences, whether that be even putting our graduates out on site, as well as being in the office, etc., or if they're on site, bringing them into the office. And I would say over the last 5-10 years, we've certainly seen an improvement in graduate skills coming out of college, particularly in areas like communication skills and report writing. But we still believe and we still run our program because we still think there are key fundamentals that the graduates need in the workplace. So I'll give you a flavor of what we teach in the 2-year graduate program, they're not in any order or importance as such, but we will cover things like communication skills. So understanding different personality types, how you communicate effectively, you know, verbal communication, non-verbal communication, confidence in speaking. We would do scenarios with our graduates to try and give them feedback on how they present themselves, how they present themselves confidently, and then presentation skills, how they present to perhaps a client, how they present a complex engineering problem and solution in a relatable way to a client. So how you can present, you may have the answer, but how you present that answer and how you get that short period of time to engage with either a client or a contractor as regards what the solution is, so that they can make a decision on it. Team building has been mentioned, and obviously it's a huge part of what we do. We're obviously a multi-discipline team in PM group, and we teach about obviously recognizing other team styles, other team personalities. In the last couple of years, we're now working much more across offices, across different countries. So you now get into multicultural teams, and just understanding how those various teams and their various backgrounds and educations will influence the way they will react with ourselves. Career planning is something we've introduced only recently, but it's really about teaching the engineers how they plan their own career. We have plenty of opportunities in PM group, but it's up to the engineers themselves to try and, you know, have goal setting, career planning. We obviously help them with that. We do things like appraisals. We do set objectives for year on year, but that's setting that kind of 5-year plan of where do you see yourself in 5 years? What do you want to be doing in 10 years? Is it technical? Is it managing teams, etc.? Sorry. And things like time management, organizational skills for engineers, you know, tools and techniques to manage your time effectively, to manage the information that's coming through to you effectively, things like emails, all that kind of the stuff, prioritization skills. We also do a module on leadership, and I probably should have said some of these modules we do internally. Some of these modules we get external presenters to come in and present to our graduates. So, you know, things like leadership skills. How do you lead a team? How do you mentor, coach a team? You know, how do you influence the team or direct the team? And negotiation and influencing, you know, skills about negotiation effectively, persuasion, understanding those kind of softer skills, not necessarily the technical skills of what an engineer has to understand. Sustainability, it's obviously a huge part of our business, a huge part of our clients' business as well. And it's kind of a much broader basis now to our business and to our clients' business. And understanding what sustainability, how you can measure it, what effectively it means for our clients. How do we deliver our own services effectively? And you're coming then we do obviously things like project management, which is what PM, it's a big part of what PM does. You know, complex projects, recognizing the issues around complex projects, whether that be cost, schedule, quality, multidisciplinary environments, how discipline would work together. When do you need disciplines to work on your project? Basic kind of scheduling, planning, and cost information on projects, and things like then progress measurement. How do you know whether your project is on track or is behind or is going to run over cost? How do you manage change with the client? And just generally the kind of language we use in projects. I'm thinking, earn value, critical path. So those kind of basic project management terms that get used around the office, and understanding what they mean. We also do basic legal training. How do we contract with clients? What form of contract do we use? What is our exposure? What is our liability? We would, reasonable skill and care of the engineer. What is our risk on the contract? And then how will we be paid? Down to things like, is this a fixed fee job for a scope? Is it recoverable for a scope? Is it recoverable with a maximum cap on that? All that kind of basic financial information that makes, I suppose, our engineers aware of what we need to do to stay in business. So effectively, getting into finance. So basic principles of finance, things like revenue, things like our costs, and these are, our overheads, cash flow, cash management. How are we going to get paid? When are we going to get paid? How can we keep, the cash going out versus the cash coming in, etc. on projects? And effectively then down to, how do we make a profit in PM Group? How do we grow the business? How do we stay competitive that we will continue to stay in business? And so, I've kind of mentioned there things like costs and our overheads, understanding what each of those pots of money are, and how they all add up to on a project. Measuring earn value. How is our project going off the rails? Is it going to cost us more to do it, etc. Just learn on other management skills, customer relationship. We would do an awful lot of business with the same customers year on year. So maintaining customer relationships, but also targeting sectors, new sectors out there. An example would be now the electric battery industry, electric vehicles, targeting those sectors. How do we get into those sectors? How do we get business in those sectors? So we would do a module on kind of business development, how to maintain customer relations. We often in PM Group would say that, when you have a problem with a client, it's a great opportunity to how you respond to that problem is probably can make a bigger influence on the client than if you didn't have the problem at all. If you can solve the problem, if you can be open and honest with the client, and fix the problem, there's often a better relationship with the client after that. And then obviously safety are legal responsibilities for what we design, for what we build, legal responsibilities of engineers, and our legal responsibilities under things like building control, etc. So that's really a flavor of what we teach our graduates, and the kind of skills we think our graduates need in our graduate program. So thank you.
Thanks, Paul. Maybe stop sharing that. And thanks, Cormac. So thanks to our two presenters for very insightful presentations. It's good to see that there's some thread of commonality going between all three presentations. So we're dovetailing at some level. So that's very reassuring. We'll stop recording the presentation now. We're going to go for some brief few minutes left for some questions.